Good morning, students. Now, the next topic is properties of acids. That means chemical properties of acid. We have already discussed the physical properties of acid. Now, second property is chemical property. Okay. Now, inside this chemical property, the first reaction is reaction with active metals. So, here has a here has some important things that we know. One important thing before discussing this topic, okay, we must be known to the most important topics. So this important topic is activity series of metal. See, activity series of metal in class 8 and class 9 also you have already read the activity series of metal. I think you have memorized the all of the names of this activity series of the metal. Okay, now now here has a trick how to remember the activity series of the metal, because the activity series you must be memorized. Why? Because this is also important for the next two chapters, that means electrolysis and for metallurgy. These two chapters, these things are important. Now see, lithium, sodium, barium, strontium, calcium, sodium, magnesium, aluminium, manganese, zinc, chromium, iron, cobalt, nickel, lead, hydrogen, copper, Ag. That means Ag means what? Ag means mercury, Ag means silver, Au means gold, and Pt means platinum. Now, how to remember this series? See, first of all, there has a trick in Hindi. Okay, लिखबा सर करना मग अल मंजन क्रो फिको nipub. Okay, in this activity series we consider hydrogen as a standard substances. Okay, we consider hydrogen as a standard element. Okay, in case of this activity series. Achha, from up to down, activity of these metals are decreasing. Is this clear? Now see, likba, li means lithium, ka means potassium. Okay, ba means barium, then sardkana, strontium, calcium, sodium. Okay, mag-al, magnesium, aluminium, then mangan, manganese, zinc, then Fico, chromium, Fe means Fe, that means iron, cobalt. Okay, Fico, Nipub, Ni means nickel, Pub means Pb, Pub means what? Lead. Then hydrogen. Okay, after hydrogen there has an another trick. See, high court है आपका. Okay, high court है आपका. High means hydrogen, court means copper, है means Hg. Okay, आपका AAP. Okay, Ka आपका. A means first A means what? Ag. Second A means what? Au. And third P, then this term P means what? Pt, platinum. Here Ka only it is not needed. Okay, only for these tricks. Okay, we need this Ka. Okay, now next, what is the uses of this activity series in this topic? In this topic means reaction with active metals. So we must find out the activity metals. That means which metals is active, more active, and which metals are non-active, that means inactive. Okay, not active, that means inactive. So those metal which are present just above the hydrogen, react with dilute mineral acid and produce hydrogen gas. Is this clear? That means some types of metal, those metals, say from lithium to lead. Okay, from lithium to lead, they all are situated just above of this hydrogen. Okay, that means in case of acids, acid means in case of when you use some mineral acid, weak mineral acid, that means dilute acid. Okay, so it produce all of these metals will produce hydrogen gas or liberates hydrogen gas. Okay, now the reaction, see, what will be the reaction? Zinc is also active metal. Okay, mangan. Okay, zinc is also active metal than hydrogen. So when zinc react to dilute sulfuric acid, then hydrogen gas with hydrogen gas is liberated, and also zinc sulfate, okay, as a salt is present, okay, is formed. Now when magnesium is treated with dilute HCl, dilute hydrochloric acid, then hydrogen gas is liberated and also form this magnesium chloride as a salt. Same case, iron, when iron react with sulfuric acid, dilute sulfuric acid, then hydrogen gas is liberated and as a salt ferrous sulfate is obtained, okay, from this reaction. So what will be the general reaction? When metal react with dilute mineral acid, okay, it produce or it liberates hydrogen gas as well as salt, okay. But see, we already use this HCl and H2SO4, but see, here has an important thing that we cannot use the dilute nitric acid. Is this clear? Why? See, but in case of nitric acid, it doesn't evolve any hydrogen gas, okay. Here has an exception. Actually, it is not exception, here also has a reason. So what is the reason of why dilute nitric acid doesn't evolve hydrogen gas? When any of the metal above hydrogen is added, nitric acid can never be able to liberate hydrogen gas. Why? Because you all know nitric acid is very strong oxidizing agent, okay. It's that means it converts any liberated hydrogen into water, okay. After oxidation, it converts liberated hydrogen into water. Is this clear? That's why nitric acid doesn't evolve hydrogen gas when it will react any active metal, okay. Now, but see, here has two metals. In presence of these two metals, very dilute nitric acid can able to form hydrogen gas, okay. So what will be these two metals? This one is magnesium and second one is manganese. So name the metals which can liberate hydrogen gas from very dilute nitric acid. Acha, see, very dilute nitric acid means what? 1%, or you can use 2% nitric acid. So how will we produce the 2% or 1% nitric acid? So in case of 1% nitric acid, first of all 1% nitric acid means what? Nitric acid solution, na? You take 1% nitric acid and 99% of water. See, in case of very dilute nitric acid, the oxidizing property of the nitric acid will be less. That means it loses its oxidizing property, okay. That means then when it loses its oxidizing property, then what happen? Then it also be able to liberate hydrogen gas when it react with active metals, okay. Active metal means which are already situated above the hydrogen, okay. So this is the two metals. See, this is the reaction. When manganese react with nitric acid, then manganese nitrate and hydrogen gas will liberate. But this nitric acid will be very dilute nitric acid, very dilute, okay. That means 1%. Is this clear? Now second reaction is reaction with metal carbonates. Metal carbonates means when carbonates. Metal carbonate means what? Metal carbonate means any other kind of metal, means magnesium carbonate, zinc carbonate, okay, ferrous carbonate, metal, any other kind of metal carbonate, okay. Now this is the general reaction. When metal carbonate react with dilute mineral acid, it produce carbon dioxide gas, water and salt, okay. When metal carbonates react with dilute mineral acid, it produce carbon dioxide gas, water and salt. This is the general reaction, okay. Now give some example. Now we have taken some example. See, magnesium carbonate, this is also metal carbonate. When it react with dilute sulfuric acid, it produce carbon dioxide gas, water as well as the salt. Salt means which type of salt? Magnesium. Here magnesium metal is present, that means magnesium sulfate, okay. Now zinc carbonate, in presence of dilute HCl, it liberates carbon dioxide gas and also water and also zinc chloride, because here zinc metal is present. In case of ferrous carbonate, what happened? In case of ferrous carbonate, when react with nitric acid, dilute nitric acid, it produce carbon dioxide gas, water and ferrous nitrate, okay. But how will you identify this gas, that means carbon dioxide gas is liberated from this reaction, we know, but how will you identify this carbon dioxide gas? See, carbon dioxide gas has a common property, you all know. This property means what? It turns lime water milky. Okay, if carbon dioxide, in presence of lime water, carbon dioxide always turns lime water milky, then we can easily consider that this gas is carbon dioxide. Okay, now this reaction is completed, reaction with metal carbonates. Now the third reaction is reaction with metal bicarbonates. This is very easy. Bicarbonate means hydrogen carbonate. Okay, hydrogen, only one hydrogen atom is present. Okay, so metal bicarbonate, when metal bicarbonate react with acid, it also produce the same product. See, same product, that means carbon dioxide, water, and also salt. Okay, salt, is this clear? Salt of this metal, which metal we will use in this reaction. So we have taken this equation. So first of all, calcium, what is the name of this compound? Calcium, not carbon. This is what is the name of this compound? This is the calcium hydrogen carbonate, or you can say calcium bicarbonate, because see here hydrogen atom is present. Okay, when react with hydrochloric acid, that means this is the mineral acid. This is the weak, that means dilute mineral acid. Okay, it produce carbon dioxide gas, water, as well as the salt, calcium chloride. Okay. Now fourth reaction is reaction with metal sulfides. Sulfides, what is the formula of sulfide? SO3 2-. This is the formula of sulfides. See, metal sulfides when react with dilute mineral acid, then it will produce sulfur dioxide gas, water, and salt. See, give some example. We have taken some example. See, sodium, what is the name of this? Sodium sulfite, SO3-. Okay, SO3 not minus, SO3 2-. When sodium sulfite react with dilute hydrochloric acid, it will produce sulfur dioxide gas, water, as well as the salt. Salt means which salt? Sodium. Okay, because here sodium metal we have taken, so sodium chloride. This is what is the name of this? Zinc sulfite in presence of dilute sulfuric acid. Okay, it will produce sulfur dioxide gas, water, and zinc sulfate. And the third reaction will be magnesium sulfide when react with dilute hydrochloric acid, it will produce sulfur dioxide gas, water, and also the salt. Salt means which salt? Magnesium chloride, because here magnesium metal is present. Okay, now see, here sulfur dioxide gas evolves out. Okay, from this reaction sulfur dioxide gas evolves out. But how will you identify this sulfur dioxide gas? See, sulfur dioxide gas has the two special property. Okay, in case of when you have taken sulfur dioxide gas in presence of potassium dichromate. Okay, sulfur dioxide turns potassium dichromate from orange chromate solution from orange to green. Okay, what is the name of this? K2Cr2O7, potassium dichromate solution. What is the color of this solution? The color of this potassium dichromate is orange. But when you pass some sulfur dioxide gas into this potassium dichromate, the color changes from orange to green. Okay, then you will easily identify the sulfur dioxide gas is present. And the other properties in presence of potassium permanganate. Okay, when potassium permanganate is present in sulfur dioxide gas, or you can pass some sulfur dioxide gas in potassium permanganate solution, then what happened? The color of the solution turns colorless. Okay, from pink, because the actual color of the potassium permanganate is pink. So from pink to colorless, the color change from pink to colorless. Is this clear? Then you will easily identify the sulfur dioxide gas. Okay, now fifth reaction is reaction with metal bisulfide. Same reaction. Metal bisulfide means what? So when sodium bisulfide react with hydrochloric acid, that means dilute hydrochloric acid, then it will produce sulfur dioxide gas, water, and also salt. Salt means sodium chloride, because here sodium metal is present. Now sixth reaction is reaction with metal sulfides. Okay, so here two types of sulfide we will use. First of all, sulfite, and this one is sulfide. So the formula of the sulfite is SO3 2-, and the formula of sulfide is S2-. See, here we have taken some metal sulfide in presence of acid. It will produce hydrogen sulfide gas and also salt. Okay, hydrogen sulfide gas has a specific smell, rotten egg. Okay, has a specific smell just about the rotten egg smell. Okay, comes out from this hydrogen sulfide gas. Now see this reaction. This is the zinc sulfide. When react with HCl dilute hydrochloric acid, it produce hydrogen sulfide gas and zinc chloride salt. Okay, see, same iron sulfide, lead sulfide, same. It will also produce this hydrogen sulfide gas, both of these in presence of HCl, and it also presence of sulfuric acid, then ferrous chloride and also lead sulfide. Here H2S gas has also special property, physical properties. This has a characteristic smell. That means the smell of the rotten egg comes out from this gas, H2S gas. But here has also chemical property. It turns lead acetate paper black. Okay, that means H2S gas turns lead acetate paper black. Okay, this is the special character of this H2S gas. Now the next reaction is reaction with chlorides and nitrates. Chlorides means Cl minus and nitrates means NO3 minus. Okay, few chlorides and nitrates react with dilute H2SO4 and dilute HCl. See, you all know barium chloride. When react with H2SO4, then it will produce HCl and barium sulfate. Barium sulfate, this is the white color precipitate will form. White color precipitate will form. Okay, now this is the lead nitrate. When react with sulfuric acid, dilute, all are dilute. Okay, sulfuric acid, then nitric acid is also produced, and lead sulfate as a precipitate it will produce. Okay, now otherwise chlorides and nitrates react only with concentrated H2SO4 on warming to liberate HCl and HNO3 respectively. See, here is a condition, that means condition of temperature, dependent upon the temperature. When you have taken NaCl in presence of concentrated H2SO4 and temperature will below 200 degrees centigrade. Okay, temperature will remain below 200 degrees centigrade. Then which product will obtain? Sodium hydrogen sulfate, or you can say sodium bisulfate, and also HCl. Okay, in presence of, but when you have taken this temperature just above the 200 degrees centigrade, then what happen is NaCl react with concentrated H2SO4, but temperature will be above 200 degree centigrade. Then only sodium sulfate produce, sodium sulfate and also HCl. Okay, same reaction, potassium nitrate when react with concentrated H2SO4, but temperature will below 200 degree centigrade. Okay, so which product will obtain? Which product will be obtained? Then see, potassium hydrogen sulfate or potassium bisulfate and nitric acid, and see if the temperature will above 200 degree centigrade, then potassium sulfate and nitric acid. Okay, these four reactions are important. Okay, now next and the last reaction is neutralization reaction. You have already read this type of reaction. Neutralization reaction means what? When acid react with base, then salt and water will be produced. Okay, now base means what? Base means metal, one type of metal oxide or metal hydroxide. Base means what? Base means one type of metal oxide or metal hydroxide. Okay, now first reaction is when acid HCl react with zinc oxide, it will produce salt ZnCl2 and water. Okay, H2SO4 when react with magnesium oxide, it will produce magnesium sulfate and water. See, this is the metal oxide, but when we have taken the metal hydroxide, that means base, this is also base, na? HCl react with sodium hydroxide, it is very easy, sodium chloride, salt and water. When carbonic acid is also react with potassium hydroxide, then potassium carbonate, okay, will form as a salt, and then water. Okay, water is also obtained from this reaction. See, so neutralization reaction means what? Neutralization is the reaction where H plus ions liberates from acid. See, H plus ion liberates from acids and OH minus ion liberates from base. Then they can come contact with each other, and then they come closer to each other and they form water. Okay, from H plus and OH minus they form water. So this is called the neutralization reaction. Okay, these are all the reactions of present in the acid. Okay, we have already discussed all of the reactions of acids. Now next I will discuss the base. Thank you.